Here's a practice problem, complex circuit. We're just going to calculate the total current through the circuit. So it's just like a regular Ohm's law problem, except it's complex. So instead of resistance, it's going to be impedance. And impedance is the real part, which is the resistance, and the reactance, which is the imaginary part. So we need to figure out what the impedance is and then work out the current. So that's the plan. We're given voltage, 120 volts, frequency 60 hertz. So this is the source, 120, 60 hertz. The inductor is 700 millihenries, and the resistor 250 ohms. Ready? All right, let's do this. So these are the steps. First, we have to find Z. So we know that Z has the real part and the imaginary part. And the imaginary part is Jx, which is inductive reactance. And inductive reactance, we use the inductance we're given, we figure out X, we put it in here, use the R we're given, figure out Z. And then once we find that, then we have to convert it to polar form, or some people say phasor form, so we find out what the magnitude of the impedance is, and then we use that in the Ohm's law, V equals IZ, instead of V equals IR, figure out the current. So that's what we're doing. So step one is back here. So R, they gave that to us already. That was what was it? 250 ohms. And we don't know that yet. We know L though. We know L was given to us as 700 millihenries. So 700 milli, like that. F was given to us, 60. We know what pi is, we know what that is. Everything else we can work out. So we're going to do that. So Z equals 250 plus J times 2 pi times F, which is 60, times L, which is 700 milli. So 250 plus J times all that stuff. Okay. So 700 times 10 to the minus 3 times 60 times 2 times pi, 263.9. There you go. So now we have Z. This is Z in rectangular form. Are we done? We're done step one. Step two, we have to convert this into polar form. So we know that's a 250 plus 2, so let's draw a little picture here. The real part is the resistive, the imaginary part is the reactance. So over here would be 250, and then up would be 263.9. And this would be the magnitude of the impedance. So we know that's the angle, so we can say, that's the hypotenuse. How are we going to figure that out? Well, Pythagorean theorem. 250 squared plus 263.9 squared. So the magnitude is going to be the square root of that. Let's work that out. So 250 squared plus 263.9 squared equals square root 363.5. Now, the angle we can find, we don't actually need it for this problem, but we'll find it anyway. So we say tan of theta is going to be opposite over adjacent. And that would mean that angle is equal to inverse tan of the same. Like that. So I can do that. I can say 263.9 divided by 250, inverse tan, 46.5 degrees. Yeah, actually if I round the 5.4 to that is 5.55, so let's say 5 degrees. There we go. Okay, so that part's done. The magnitude of the impedance is this, and the angle is this. So we converted the rectangular up here to the polar form or the phasor form. So you could say that Z is equal to 363.5 with an angle of 46.55 degrees. So now step 3, find the current. Well, V equals IZ. That means I is going to equal V over the magnitude of Z. V, from before, V is 120. So let me say 120 divided by the magnitude, 363.5. 120 over 363.5. .33 amps, which is equal to 330 milliamps. Done. There you go. That's how you do it.